Hey, Dr. B here, and let's do a gas law problem that involves density. Let's derive the density equation, and here's how it works. Well, you know that density is mass over volume, but we can say that for 1 mole of a gas, V is equal to RT over P, where R is the ideal gas law constant, 0.0821 liters atmosphere over mole Kelvin. T is the temperature in Kelvin, and P is the pressure in atmospheres. And the reason that's true is because the ideal gas law is PV equals nRT, and it says each mole. So if N is equal to 1, we can rearrange it because N is 1, and so it's just V equals RT over P. We plug that in there, that's what V is, and we get the density of a gas is equal to its pressure times its molar mass divided by the gas law constant times the Kelvin temperature. That's interesting. And here's a question. A chemist has synthesized a green yellowish gaseous compound of chlorine and oxygen. I'm guessing it's very toxic. He finds that its density is 7.71 grams per liter at this temperature and at this pressure. They want you to find the molar mass of the compound and determine its molecular formula. We're not solving for D, but we are solving for M, so let's rearrange. There it is. M equals dRT over P. We should be able to plug in directly. There's the density. I think grams per liter is fine. We better use temperature. There it is in Kelvin, and the atmospheres is also good. The molar mass of this thing is 67.9 grams per mole. We're halfway done. We also need to determine its molecular formula. Well, it's chlorine and oxygen, so why don't we start with one of each and see where we stand. One of each brings us to 51.5, too big to add a chlorine, but just right to add another oxygen. It must be ClO2. This is a gas law problem involving density.